Okay, so part 1 of 2 in breaking down the unit circle and going just a little bit slower with all of it. So degree measures. When we take a look at the unit circle, there are a couple of ways to work through. So let's start this way. If we start here at 0 degrees, if we look here in the first quadrant, the middle one is always halfway through. And most of us are pretty comfortable recognizing that that would be a 90-degree angle there. So halfway through would be 45. That means all of my halfways are counting by 45. So 0, 45, 90 plus 45 is 135, plus another 45 sets me at 180 degrees. Another 5 is the 225, plus 45 brings me to 270. And then 315 until finally I circle back around and I can call that again 360 degrees. So counting by 45s, those all work. The other two, if I can try to ignore the 45 that's there, I'm splitting into 30-degree increments instead. So if I work on my 30s, I have 30, 60, 90 is already labeled. 120, 150, 180 is already labeled. 210, 240, 270 is already labeled. And then I would have 300 degrees, 330 degrees, and then circle back to 360, which again is already labeled. So the degrees of all things unit circle, I would expect we would be most comfortable with. I would recommend at this point pausing and looking at a blank circle and seeing if you could do this on your own. The more practice you do recreating it from scratch on your own, the easier it's going to be to remember all of these different parts. So radians, maybe a little bit tougher because we simplify the fractions. And so I'm going to write both and then end up with a simplified fraction. But remembering that 180 degrees is equivalent to pi. And so some of my big ones then, 360 would be twice that, is my 2 pi. And half of 180 is 90 degrees. And so that would be half, or it would be written as pi divided by 2. So the same sort of thing happens here. If I start with pi and think of my pi over 2, then I'm splitting the entire circle really into 4 parts because I have 2 pi here at the end. So from 0 to a half to 1 full to 1.5 to 2 is where I can mark really what my x and y axes I would think of. And so that's why I end up with 3 pi over 2 at the bottom, because that is essentially my 1.5. So I start at 0 degrees or 0 radians, and I go to a half, a whole, 1.5, and then 2 as I work my way around to each of these 4 parts of the circle. Then it is breaking the rest of them into parts. So the same logic that we had used with the degrees, if my 30 degrees fits into 90 3 times, then if I take my pi over 2 and take a third of that, then I can recognize that as pi over 6. Or if I just wanted to convert degrees to radians, if I take 30 and multiply by pi over 180 degrees for that conversion factor, 30 pi over 180 simplifies to pi over 6. So if I count off as pi over 6, 2 pi over 6, which will simplify, this would be 3 pi over 6, which is simplified, 4 pi over 6, 5 pi over 6, 6 pi over 6, which again is simplified, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, and 11 pi over 6. So again, lots of values, but things that I can, again, simplify. And that's what the final version of the unit circle ends up looking like. The missing pieces that I have are my 45 degrees. So I could do the same thing. I could think of pi over 2, and I could cut it in half and end up with pi over 4. You could think of the 180 cut 4 ways. So that's pi over 4. Or again, I could just take 45 degrees and when I multiply that by pi over 180 to do my conversion, 45 pi over 180 degrees is 1/4 pi, or pi over 4. And so at 45 degrees, I have pi over 4. And then I would have 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, and it would finish at 8 pi over 4. And I should have also finished off there with 12 pi over 6. Oh, not a triangle. 12 pi over 6. So again, then I just need to simplify all of these values. And so the ones that I want to keep to work through, I have my pi over 6. That is a terrible pen. I have pi over 6. That is not changing. I have pi over 4. That is not changing. 2 pi over 6, though, is the same thing as pi over 3. 2 pi over 4 is 1/2. 3 pi over 6 is 1/2. So this just remains pi over 2. 4 pi over 6. 4 and 6 are both even numbers. That reduces to 2 pi over 3. 3 pi over 4 stays. That's reduced. 5 pi over 6 stays. That's reduced. Pi stays. Those get reduced. 7 pi over 6. 5 pi over 4. 8 pi over 6 becomes 4 pi over 3. This I already had simplified at 3 pi over 2. 10 pi over 6. 10 over 6 is 5 pi over 3. 7 pi over 4. 11 pi over 6. And then again, my 2 pi is my neatest one. And so again, quite a few of these just stay as they are. And a few other ones just need to be simplified. Excuse me. To see my final version. And whatever work you need to do in creating the unit circle so that you can see that most simplified version. And it, again, is something that for what we are going to work on, you should have as a reference in front of you. And so you don't have to remember where all of these things come from so much as you just have to use those values. So that being said, I would look at these key values at the top, just recognizing that 180 and pi are equivalent, because that helps with these conversions that we did here, explaining some of those increments. So hopefully this slower version of it, and again, just like I said after the degrees, try it on your own. Stop and try on your own, compare back to the answers. The more practice you have with it, the easier it's going to see the pattern in these numbers. Easier it will be to see the pattern in these numbers.